All right, so we're looking at the 2024 AP Calculus FRQ number 5. If I have any mistakes, I will put it in the pinned comment below. So consider the curve defined by this. It can be shown that dy dx equals negative 2x over 3 plus 4y. Okay, so they didn't ask you to do that. There's a point on the curve near 2, 4 with x coordinate 3. Use the tangent line at the curve to approximate the y coordinate at that point. Okay, awesome. So for this one, you're just literally going to do slope point form. Y minus y0 is mx minus x0. In this case, we already know the point. So it's y minus 4 is mx minus 2. So this is the equation. This is the how we find the equation of a tangent line. So m is going to be the derivative at this point, right, at 2, 4. Which means I'm just going to plug 2, 4 into this thing because that's the derivative. So it's negative 2 times 2 over 3 plus 4 times 4. And that's negative 4 over 3 plus 16. Oh, gosh. 3 plus 16 is 19. Okay. I don't know. I just got to do mental math here. So y, and then I'm going to move the plus 4 over. So it's negative 4 over 19, x minus 2 plus 4. And so that is our equation of the tangent line, and we want to approximate the y-coordinate. So the x-coordinate is 3, so we're going to plug in x equals 3. So then y is approximately equal to negative 4 over 19, 3 minus 2 plus 4, and I would just leave it like that, honestly. Whatever you want to simplify that to. I will simplify it, but like for suggestions for tests, they just tell you just leave it like that. But this is negative 4 over 19 plus 4. For those of you who bothered to do that, which I think would be like a huge waste of your time. But for those of you who bothered to do this and you made this, 76 over 19? I think that's right. Yeah. That would be 72 over 19. I just put it in there, but honestly, just leave it as that as your answer. Okay, part B. Is the horizontal line y equals 1 tangent to the curve? Give a reason for your answer. So we want to know if it's tangent to the curve. So two things have to happen. It has to be on the curve, and it has to have, so it has to be on the curve. So it has to intersect it, or intersect the curve. That's the way. And the dy dx has to equal 0 at that point, at that intersection. Right? That's what it means to have a horizontal tangent line. So let's find when y equals 1. So we plug in y equals 1 into here to find the x coordinate, because I need to know the point. So this is x squared. This is 2 plus 3. It's 5. 48 minus 5 is 43. Gosh, they really did this to you? Okay, fine. X is equal to square root of 40. Okay, and then the dy dx at this point, root 43 comma 1. They really do that to you just to make you like do this? Okay, negative 2 root 43. Well, I guess it's pretty easy to tell that is not equal to 0 because the numerator is not 0, right? So, no, it is not. It is not tangent to curve. It intersects the curve. Okay, it intersects it at this point, but the slope is definitely not 0 at that point. Okay, curve so another way you could do this, by the way, is you could say, well, it only has horizontal tangent lines when x is 0. So then you have to say, like, well, is x 0, y equals 1 on the curve? And that would be no. So then that's another way you could justify it instead of doing all of this. Okay, the curve intersects the positive x-axis at this point, root 48. So that's when y is 0. So that makes sense. Is the line tangent to the curve at this point vertical? Give a reason for your answer. So that would occur if the slope was undefined. So we're going to evaluate this at root 48 comma 0. You're going to get negative 2 root 48 over 3 plus 4 times 0. And that's going to be negative 2/3 root 48. And this is a defined slope. So again, no, it's not vertical because the slope is defined, right? And specifically, the slope is this guy right here, right? So no, it's not a vertical tangent line because otherwise the slope would have to be undefined, right, for vertical tangent lines. For time t greater than or equal to 0, the particle is moving along another curve defined by this equation. At the instant the particle is at the point here, the y-coordinate of the position is decreasing at a rate of 2 units. So this is a related rate question. They're saying dy dt, the y-coordinate of the position, y is the y-coordinate. The related time is -2 units per second. At that instant, what is the rate of change of the x-coordinate? I would like to know what dx dt is equal to, right? And so how do I do this? Is first I identify the rates. This is the rate. This is a related rates question. This is the rate I'm looking. This is the rate I know. This is the rate I'm looking for. And how do I relate them? Well, I have an equation that relates these two things. So they give that to you already. And so then my goal is just to take the derivative, and it's almost like implicit differentiation, but you're just going to do 3y squared dy dt plus this. I have to do product rule because I'm multiplying two things. So derivative of 2x is 2dx dt times y, and then swap it, 2x times the derivative of y, which is dy dt, and derivative 24 is 0. And now we plug in our -2 here, and we want to solve for dx dt. So we know that dy dt is -2, this is -2, and we have the coordinate that is occurring, that's 4, 2. So that means all the x values are 4, and the y values are 2. Okay? So then, what do we do with that? Is we say, well, then that's going to be 3 times 4 times -2. 4 times -2, I don't know, 4 times -8. 2 times 2 is 4, dx dt. And then this thing is going to be 8. 8 times -2 is -16. So -16 equals 0. And then we're just going to solve for dx dt. Now, at this point, you don't have to do as much arithmetic. You could do 16, and then this is plus 24 over 4, and you could just leave it like that. What is the rate of change with respect to time? Oh, okay, that's it. So that's units. Because they gave you units per, what was the units they gave us before? Units per second, Might as well write that in there. I don't think you'll get docked for not having that in there. But if you want the exact number, what is that, 10? I think 40 over 10, that's 10 units per second. Entirely possible. I made an arithmetic mistake. You guys will point that out to me if I did.